I mentioned before, again, project specific, based on what you're doing, what the scope of the work is, how detailed you are in different things that we are doing, and also what stage you're in. So again, the typical section generator is still there. It's still part of it. You guys will still be using that, especially at the beginning, or if you have a simple section that maybe it's a write-up job and you're not doing a model or anything, you have a typical section you have to show. You're still going to be utilizing those things. What we're trying to get to in this, again, as I just mentioned a minute ago, is utilizing our design model itself. So like for typical sections, starting to get into the habit of utilizing our cross sections that are cut from our model and our design. Couple of things that it does is when my model changes, my corridor changes, the design changes, it will update my cross sections. My cross sections change. What it also does is it gets us as an industry to start cutting cross sections quicker, sooner than waiting till the very end and cutting the sections. The bigger thing that it does is, again, when my design and my model changes, it can update through everything. I'm not going through and redrawing a whole bunch of things and trying to match something. So it creates less rework and less work on that end of things. And it also reduces that risk, because then that risk is pointing to one space, not a bunch of different spaces. So what you see here is a drawing model of typical sections. And what I'm going to go through, and really was more to kind of save time, because instead of just starting with a blank sheet and then just bringing in a bunch of information, I'm going to walk through with the references and how those were brought in. So I'm in my drawing model, and what I have is I have different sections, as you can see through here. So again, bottom main section. So you can see it kind of highlights it, and there's some clips and some different things that go on there too. Again, it's not exactly clean. You can just take your section, put it in. You're gonna have to turn a few levels on and off, probably depending on what you want to show on your typical section. But your cross section has the detail to match the typical sections to put that in, which means your model, your design, your plans, everything propagates through that. So you'll also see, and I'm just using the main one since it's showing up in here, this bottom one. You can see I have different stationing. Well, that stationing corresponds to my cross sections. So what I have referenced in is I'm referencing my planned cross sections that I'm using for my cross sections for the project itself. And I can go in and I can say, okay, a typical section, so the section that's going to be typical is the one that I want to reference in here. So I go ahead and I select from that. I'll pick that reference. When I pick that reference and it comes in, notice I have a nested depth of 2 and not 1. The reason why I have a nested depth of 2 is because my cross sections read my design model. So in order for that same line work to come across from the cross sections to the typicals, I need a nested depth of 2. So it brings my cross section and my design from that area. So that's how I get the cross section to come in. When I bring it in, notice it says description standard top. That's because of how I brought it in. When you bring it in, you have your options through a reference file to bring that in. You can pick from coincident world. I want to pick top or whatever. Well, if I pick top, I can just I can place that where I want to. So I can have my border set up that's going to print within my sheet, and I can drop my sections in there. So that's how I'm utilizing my cross sections to display as typical sections in my typical section plan. So with that said, you can see this section just has the one section itself. And again, you're going to have some clips because you may have to clip a few things off that might be in your sections that you don't want to see. Maybe you don't want to see all your utilities on your typical sections, which you won't. So that's some of the things you can either clip those out, turn them on and off, depending on what it is. You're also going to see, I have a bunch of different sections in here. So you're going to see top, bottom, left, middle, right, drop downs. So similarly, I can still do drop downs from sections that I want to by referencing in that section. So if I reference in that section, notice that it's clipped. So I'm doing the same thing I did down here where I reference in the section itself. I line it up based on, again, we've talked a bit before about backbone method, how we do the modeling from a backbone method versus just a traditional template method. Well, on my end conditions, if I have a separate end condition that I want to show, okay, it's going to do this from here to here, but my roadway width is going to stay the same, the striping is going to stay the same, then I can go ahead and pull that drop down in. All I'm doing is clipping that drop down and showing what I want to show for that end condition. So again, if my design and my model changes, my cross sections change, my typical changes, all from one unified data source, which is my model, my design model. So if I have cross sections and then my model changes and my information of the dimensioning that I've done from the dimensions, those are going to show up. So like, let's say that the sidewalk, we decided, hey, we need a much larger sidewalk in this area. We need to do a 8-foot sidewalk. So we go in the design, we update everything. It updates all the way through, updates through the cross sections, updates in my typical sections. I now have a broken dimension, and I also see in my section, this is now over here. So I modify my dimension. So again, it's also another QC check, and it's a QC check of how that works with my design model, because my design model changed, so my typical changed, so I can update that change. Prior to just drawing in a typical section, model changed, didn't get communicated to who's in charge of the typicals. Typical doesn't get changed. Well, now I've got a 5-foot sidewalk on my typical, but my plan view and my cross section show an 8-foot sidewalk. So what we're trying to do is eliminate some of those errors. One thing that this has helped us with in a real life scenario are our pavement sections. So typical sections were drawn. The typical section itself showed a pavement section. So the pavement depth was 10 inches, and then the ABC was 6 inches. Well, a new geotech report came in. The typical section needed to be updated. The pavement thickness stayed the same, but the ABC went from a 6-inch to an 8-inch. What wasn't reflected in the typical sections was that pavement depth. And also what wasn't reflected in that pavement section was through here, through the pavement section itself of what that depth was. When we went to having our typical sections referenced from our cross sections, we were able to catch that very quickly, because now my design and my quarter model that had 8 inches, because I updated my design and my model, it updated all the way through my cross sections to my typical sections. So I was able to make sure that everything was verified against each other and checked each other. So that's one of the main reasons of why trying to move to, again, details, typical sections, anything we can use from our design and our model as one unified data source is going to mitigate risks. It's going to reduce some of the work that we're doing drawing by hand, where we can spend more of that time on our design intent and our modeling versus do things match up that I hand drew versus what I actually modeled and designed. So again, this is the drawing model. So similarly, you will end up with the drawing model, and then your sheet model, like Schwab showed, as far as, and you can see here's the symbol moved over to the right. The same thing, the sheet's set up now, it's referencing that drawing model that we have in. Notice it's a nested depth of 3, because we've got to bring that information across into my sheet. If it's 2, nothing's going to show up in here except my dimensions. My cross sections go away, because I need my cross sections to represent my typicals to come across into my typical section sheet itself. So with that said, this is a real live project, was used on a project, as you can see, and I don't want to go too far with that, but again, these were used for a project. The project had pretty decent results all the way through construction. And so we were able to utilize one unified data source. It did reduce errors, it mitigated risks. It let us concentrate more on the design itself versus trying to draw in other things. So this is and this was a CDOT project. So it was basically a beta test of what we did, and had great results come out of it. So again, this may not be applicable to every single project that's out there. It's probably going to be project specific, but I would say really the main point of this is the more we can use our models and our design, the less errors we're going to have, the more we're going to be able to mitigate risk as we go through. So that's kind of the point of this one. And any questions on typical sections and how those work?
I just want to have add quick comment here. I know on a given project, we do existing typical section and proposed typical section, and in the past we used to have the quality assurance document when we tell everyone, we encourage everyone to cut cross section of the existing, like you receive the existing and you have your terrain, you receive geometry existing, and then you cut your cross section and you actually look and see what is pavement and roadway doing with the existing surrounding and stuff before you start. That can be cut to be also here to show what the existing typical is, and then once you do your model will be the proposed. And this is something maybe we should remind everyone who is in the future in the training to do.
Yeah, I mean, any section, again, anything that you can utilize from your model and your design that you can reference, that can go back to that, again, that unified data source, then the better we're going to be, because then we are just mitigating risk at that point and reducing errors.
Very good.
Okay, so no questions on that. Okay. So I guess, Sahara, if you want to stop recording, and then we'll start up again. I'll switch over